Now we're going to prove the Pythagorean identity by using the unit circle. So I'm just going to draw a little unit circle divided into 4 quadrants. And we know our radian on a unit circle always equals 1. Our unit circle equation is x squared plus y squared equals r squared. Now I'm just going to come down here and draw a little unit circle with a radian measure of 1. And this is going to be x, this is going to be y, and this is 1. We know our x is going to equal our cosine theta, and y is going to equal our sine theta. So I'm going to draw a big one. Divide it into its 4 quadrants. And I'm going to draw another big one. And this is going to be our cosine theta. This is going to be our sine theta. And we know this is 1. Now, on the unit circle, you can use a triangle's cosine triangle coordinates to help you prove the Pythagorean identity. And this point will be our point where our cosine and our sine intersect on the unit circle. But you can have points anywhere on your unit circle. They can be on the top or the bottom. They can be positive or negative. So I can have some here, 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 or here. But today, how we're going to prove it is we're going to use the angle measure 180 degrees. And the coordinates for our angle measure 180 is -1, 0, which is x and y. Now, I'm going to just rewrite our unit circle equation, which is x squared plus y squared equals r squared. Another way we could write this is the cosine of theta squared plus sine of theta squared equals 1 squared, which is just our x and our y. And our x is -1 squared plus 0 squared equals 1 squared. Negative times a negative gives you a positive. That's just 0, and that equals 1. Now, we know that we proved this correctly because we know when we derived it, we got sine squared theta plus cosine squared theta equals 1. And we have 2 1s. So it's correct. So basically, all we did was we used our angle measure at 180 coordinates, which were -1, 0. We plugged them into our unit circle equation, which is the same as cosine theta and sine theta. And we solved, we got 1, and it equaled the Pythagorean identity.